So good afternoon and welcome to the Scripps Technical Forum. Welcome you again to our online series. I'm Douglas Altman. I'm the lead engineer with the Center for Western Weather and Water Extremes here at Scripps. In addition, I function as the STF chair and get assistance setting up and running STF from my colleagues here on campus, Gwen Nero and Vanessa Scott. Gwen is the Director of Corporate Affiliates, Business Development, Industry Outreach, and Innovation, and Vanessa is an Industry Relations and Innovation Analyst. If you have missed any of our previous presentations, you can find them on the Scripps Technical Forum playlist on the Scripps Oceanography YouTube channel. You can also find links to PDFs and recorded webinars through the STF website. And let's see here, just be aware that the presentation is being recorded, and you, as I mentioned, it can be found in the future on the stf.ucsd.edu website. If you have a question that you want to ask one of the speakers, please put it in the Q&A. You can also unmute your mic if you want to do that in real time. That's an option there. And the speakers have said that you can interrupt during the presentation, or we can hold your questions to the end. So today we have a presentation by Andrew Thomson and Paul Gannett from Onset. Andrew and Paul will provide a brief overview of Onset's HOBO water quality and depth data loggers and data access options, and we'll discuss 3 case studies: the Billion Oyster Project, Buzzards Bay Water Quality, and Bermuda Institute of Ocean Sciences, CREOL. And with that, I am going to hand it back to our speakers.
All right, good afternoon, everyone. My name is Paul Gannett, and I'm going to go through a couple of slides to get us started off. First thing, though, I want to do is thank you all for joining us today. We're excited to have this chance to talk with you. I have had the chance, the pleasure to visit Scripps a few years ago. I met with, who was it, Greg Sinnett. He gave me a nice tour of the pier, talked about his research using some of our data loggers to monitor waves and their thermal properties as they're washing into shore. I think he had like 38 of our temperature sensors and a couple of salinity sensors monitoring waves as they wash by the pier. And you probably didn't even know that there was those sensors there, but yeah, a lot of good work going on there. I also had a chance to meet with Isabel Kay, who's down at the Mission Bay, the Kendall Frost Marsh Reserve, if any of you've been down there. So I'm familiar with some of the good work going on down there. And with
Paul, are you able to see my screen? I just want to make sure.
Oh yeah, yep, I could see your screen.
Okay, all right, perfect. I just want to make sure. Thank you.
Yeah, so let me, kind of switch gears. We'll talk a little bit about Onset, and then I'll actually tell you a little bit more about my background as well. Onset's been making data loggers since 1981. We make the HOBO data loggers and the HOBO weather stations as well, which are used all around the world for monitoring environmental conditions. And we do have a network of distributors that sell worldwide. In the US, we mostly sell direct. We do have some distributors in the US as well, but you're welcome to contact us and work with us directly. And actually, you can ignore that bit about Richard at the bottom. He's just a little quick introduction to myself. I've been with Onset now for 24 years. I've helped develop most of our data loggers and stations for outdoor and underwater monitoring. I've worked extensively with a lot of these water monitoring agencies, as well as university researchers like yourselves. And just hit another click there. And I just wanted to say I'm very passionate about our products and the applications that they're used in, and working with researchers like yourselves. I live and work here on Cape Cod, where the ponds and the streams and the estuaries and the water around us are central to our economy and recreation. That's actually a picture of my son You can't really see it, but he's caught a tiny little fish that he was showing off. I think the lure was bigger than the fish, but raised our kids here, and so protecting the environment and doing research about how to sustain it into the future is really important to me. So at this point, I want to turn it over to Andrew to introduce himself and run the presentation from here.
All right. Thank you, Paul. And thank you, Doug and Vanessa, for setting this up, and also everyone for joining us today. As they noted, my name is Andrew Thomson, and I'm an application specialist with Onset. I recently joined, joined right during the COVID era. I started back in March of this year, and I specialize in assisting researchers, consultants, government agencies, and universities and others on all sorts of applications. But for today's purpose and my main focus, which is around the water quality environmental applications. So for today's agenda, we'll look at we'll look at some of the data access options and really how we're retrieving our data from some of these loggers. And then we'll get into product specific. We have water temperature loggers, light level loggers, conductivity and salinity, dissolved oxygen, pH, water level. We'll get into some deployment tips and then finish off with some customer applications, and then leave it open for a Q&A. So here you can see some of the data access options that we have, and I will kind of brief over what you see here just because we have a slide for each one. To start, we have the USB style loggers that you would offload with the Shuttle onto our desktop software. It's a proven software we have called HOBO. A lot of customers have used it for a long time. We also have Bluetooth style loggers that works with our free HOBO Connect app. And it makes it very convenient for some of our customers to kind of deploy, configure, and offload their data. And then we also have solutions for web-based programs, and this allows for that remote access to your data. So this works with our HOBOlink cloud-based platform, and I'll talk a little bit more about that in some of the other slides. So here you have the USB style data loggers, and this works again with our HOBOware Pro software. And to a lot of our water quality USB loggers that will require this Shuttle, we have two different Shuttle options. We have the Optic USB base station, and then we also have a waterproof Shuttle as well that can be used in the field and has internal memory. And I have a slide on that specifically next. So the way it would work is you would kind of configure and set up your logger right through HOBOware while it's connected to this Shuttle. And then you would deploy that logger into the field, whatever application that may be in. And then you would come back to retrieve that data logger, and either with your equipment offload with one of our base stations, or if you're using our waterproof Shuttle with internal memory, you would just bring that waterproof Shuttle. And sorry about that. So the other thing to mention here is we have the HOBOware desktop software. And this desktop software is used for a lot of our water quality data loggers, specifically because it has the graphing capabilities, but also data assistant for things like water level, dissolved oxygen to provide salinity adjusted DO. So this HOBOware Pro software is great solution for these USB style loggers. Here is a little bit more about the waterproof Shuttle. Again, the big difference here with the waterproof Shuttle as opposed to the Optic USB base station is it has internal memory. So for an application where you're deploying a lot of different loggers, or even I have applications with maybe wetland mitigation where they're deploying a ton of water level loggers, it allows you to skip the step of bringing your equipment on site or bringing the loggers back. It has that internal memory so that you can offload all of those loggers on site and keep them deployed. So this, and it also works similar to the Optic USB, where it allows that direct connection to the software so that you can set up the logger, configure it, and deploy it. It has an easy to use one button push offload to allow you to relaunch the logger. As I mentioned, you can leave it out in the field, kind of reset it to its memory. and it's waterproof up to 20 meters. So you can offload loggers directly from the water or even underwater, which is another great feature about that waterproof shuttle. It has a typical 1-year battery life. It uses 2 AA batteries. They are user replaceable, and it can offload up to 63 loggers at a time. So it will have that memory to store 63 full loggers to offload and onto the HOBOware Pro software. This one does require HOBOware Pro, but as I mentioned, a lot of our water quality products, you'll want HOBOware Pro for that data assistant. So that's usually not an added expense. So here's a little bit about the Bluetooth enabled data loggers. And again, the big key here for the Bluetooth loggers is you're able to configure, deploy, and offload your data right from our free HOBO Connect iOS and Android app. And that makes it very convenient and also gives you that peace of mind that those data loggers are in fact logging. Typically, you would have to be within about 100-foot line of sight range to access these loggers. But again, in some cases, it allows you to keep the loggers actually installed without even pulling them. And then in other circumstances, you wouldn't have to hook them up to a shuttle or your laptop to offload that data. A good thing about the Bluetooth enabled loggers in the software itself, the app, is it provides that graphing capability when you read out your data, but it also allows you to export and share that data right from your phone. So it will create files, and whether you want to share it as an XLS file, a CSV file, or even a HOBOware file that you could import into our desktop software, it provides that option to send it right from your phone. And another good feature for the Bluetooth enabled loggers is we have the cloud-based platform HOBOlink. If you have a lot of loggers in the field that you're reading out and creating those files for, you can actually set the loggers to automatically upload to hobolink.com where you could create a free account and access those all at once so that you can pull them off of your computer. So these are, we have a couple different solutions for remote data using our web-based platforms. The 2 stations that we offer, the Micro RX, which is a compact station, allows for water level and also some environmental sensors as well. And then the RX 3000, that is a more robust station and has some expanded capabilities using maybe third-party sensors, for example. Both stations are set up to handle cellular using GSM connection, and the RX 3000 station will also allow for Wi-Fi and Ethernet capability as well. And just to mention maybe some of the applications that you would see a Micro RX station getting remote data, you might have a dam management application. I have a lot of high hazard dam applications that they're using the Micro RX station for water level. They're also hooking up some of our environmental sensors like rain gauges or wind speed and direction right there. And this web-based platform in the HOBOlink, the remote access, will allow you to see near real-time data and also allow for alerts to be sent via text message or email. So you can have that set up, and there's an unlimited amount of options for that as well. You can also set up automatic exports from our software, HOBOlink, whether it's, again, Excel file or a HOBOware file that you'd like to upload into the HOBOware software. And also another key feature is the HOBOlink platform. The online platform will also provide some of those data assistance, one being water level as well, for an easy readout solution. So here are some of our water temperature and light loggers. We have a temperature solution for really all sorts of, or all applications, being a USB offload, Bluetooth, and then you could also use our remote solutions with those stations as well to get remote access for water temperature. So there's a range of different loggers up top here, all of them having a very durable housing for deployment in both freshwater and saltwater environments. There's a range of different applications that these temperature loggers are used in. And for the communication options, we have the USB style loggers that you would offload with a shuttle, and then also the Bluetooth style loggers that you would use that HOBO Connect app on your phone. The battery life, it will vary depending on either which logger you choose or maybe even the logging interval that you choose. So it will vary between 1 to 6 years. And for the Bluetooth loggers, it does allow for user replaceable batteries, which is a great feature. And the temperature accuracy with all of our loggers, it is all research grade accuracy levels. So the temperature accuracy will vary, but again, it's research grade and they all have great accuracy. The depth rating can also vary depending on the specific logger. The two loggers that you see here in the middle, the Tidbit family, this is from our Bluetooth Tidbit family of loggers. The yellow one being a 400-foot depth rating, and then the orange being a 5,000-foot depth rating. So it works in a number of applications. And then also those same tidbits, this is a neat feature and one that some of our customers will use for maybe intermittent stream monitoring or even for stream temperature monitoring. And there's a water detection feature on that tidbit logger that will show in the data when you read it out as an event of whether the logger was in or out of water during that recording. It will continue to log temperature, but point to that data so that you can maybe sort the data out on Excel to only show when the product was in water, or if you're looking to actually map presence of water throughout the year, it really helps with that application as well. So here is, we have two conductivity loggers, one being a freshwater conductivity data logger, typically for applications that would be maybe pollution applications. So maybe mine runoff or road salt runoff, things of that nature. And that logger will get up to about typically, I think, 10,000 microsiemens per centimeter. And then we have the saltwater conductivity logger, both designed very similar. But the saltwater conductivity logger will obviously give you a much higher reading for conductivity and also will provide a salinity reading. The great thing about the HOBOware Pro software, and as I kind of mentioned about using those data assistant, this is where you'll start to see it with maybe the conductivity logger. And that data assistant in our HOBOware Pro software will allow for start and endpoint calibrations to compensate for any biofouling in a linear fashion during that deployment to give you the highest rate of accuracy. And also this HOBOware software will provide an easy conversion to specific conductance and salinity using the practical salinity scale. They're made up of a rugged Delrin housing for deployment. So again, in both freshwater and saltwater deployments. And this is one of our USB style loggers. So it can use that USB optical interface and also the waterproof shuttle for high-speed data offload. And the sensor face allows for easy access. So it's a great design and allows for easy access to the sensor for cleaning and shedding air bubbles. And then the battery typically is around 3 years. Again, that's going to depend on the logging interval, but it's a 3-year battery life and it is factory replaceable. So you can send it back into Onset. They're very, rugged, durable products. So if it's something that you are just, if you just need a battery replacement, you can send it in for us and continue to use that logger. Or you can do a tune-up as well for the internal components of the logger.
Andrew, I've got a question. It's Douglas. I was just curious as far as the conductivity sensor, is there any issues with biofouling and how do you deal with that?
So, and Paul, if you want to back me up on this, but I'd say that it's really dependent on the length of deployment and also the environment. So the environment could increase biofouling and also the length of deployment could do that. So it's really key, I think, to note or know beforehand what you're kind of up against when it comes to biofouling to kind of either correct for it or set your deployment. If you're looking at an area with a lot of biofouling, you might want to have a deployment that's less than a month. So that could really depend.
Yeah, just to add to that, biofouling is obviously an issue in any sort of coastal estuarian sort of application. And a couple things I'd recommend in terms of deploying them is one is to deploy it inside like a PVC pipe because that cuts down on the light that's getting to the logger, and that will reduce the amount of biofouling. And then the second thing to do is to wrap a copper mesh screen around that PVC pipe or around the logger itself, because the copper mesh will also reduce the amount of fouling. And so those two things will help. And again, depending upon your environment, you may have to get out there as frequently as every week or two to clean them, just to be sure that the fouling isn't affecting the measurements too dramatically. As Andrew mentioned, the face is pretty clean or pretty smooth on these. It's got a nice smooth coating on them, so you can easily clean them with a toothbrush to wipe off the fouling as it builds up before it gets bad.
Thanks for the info.
Yeah.
So here we'll take a look at Onset's dissolved oxygen logger. This logger uses RDO basic sensor technology. It has an optical DO sensor, which is very easy to replace, and Onset offers those replacement sensors. It does have a 6-month sensor cap life, so that's why we do offer that replacement. This DO logger is part of the USB family, where we're using the HOBO Pro software to offload our data and using those USB optical interfaces or the waterproof shuttle. And the software will provide salinity adjusted DO concentration and DO % saturation as well. So again, the HOBO software, the Pro software, really helps with kind of streamlining that process and doing those calculations for you. This also has a durable Delrin and PVC housing, so you're going to get those freshwater and saltwater deployments, and that's really typical with any of the products that we carry. Water level tends to be specific on the application, but the other products in water quality can be both freshwater or saltwater. This also, with the 3-year battery life, factory replaceable, and you could also do that tune-up as well if you wanted to continue to use that same product. In the user replaceable DO sensor cap. And then for this one, because we just kind of talked about biofouling, the dissolved oxygen logger actually has a anti-biofouling copper guard that you could add to your cart when purchasing this. The accuracy on these dissolved oxygen loggers, again, research grade, you're looking from, between 0.2 to 0.5 milligrams per liter, and that depends on the range, either 8 to 20 milligrams per liter. And some of, I'll kind of note a typical application that I see the dissolved oxygen logger in, and this is just one example of many, but for salmon restoration or salmon monitoring, dissolved oxygen is a very important factor for salmon life. So this dissolved oxygen logger is very good. It's rugged. It can be used for longer deployments, and we offer that anti-biofouling copper guard for those longer deployments as well. This is the pH, this is a Bluetooth pH and temperature data logger. This is one of our, outside of temperature, this is one of, and water level, this is one of our only Bluetooth options for the water quality side. And this is a newer option from Onset. Again, when we talk about Bluetooth, we talk about the convenience of it. So you actually have a guided pH calibration that you can do on site right through that HOBO Connect app. So it makes it very convenient to configure your logger and deploy it right there and do that calibration. It makes it quick and easy to do the offload as well. And again, you can share those files right from your phone, or you can access them on HOBO Link if you set it up that way, or you can upload the data to HOBOware as well. This has a rugged PVC housing, again, for the freshwater and saltwater environments. And this also, we talked about the water detection feature on the Tidbit loggers. This has a water detection feature more for the battery life, to preserve battery life and less maintenance. So when it's out of water, it's not, or when it's in water, it's not searching for Bluetooth connection. And it has a potentiometric pH electrode with a plastic body, a gel electrolyte, and a glass pH sensor bulb and double cloth junction. It is a user replaceable battery. So with the Bluetooth options, we have user replaceable batteries, which is great. It's typically 1 to 3 years, again, depending on depending on the logging interval. And the pH electrode, like the DO sensor cap, can also be replaced. So it has a minimum life of about 6 months, depending on the application. And if you find that the results are not coming back the way they should, it's a potential that you may need to replace your pH electrode, but we have those options to purchase. And like the DO logger as well, it has an option for an anti-biofouling copper guard. And again, you can see down here with the accuracy of plus or minus 0.10 pH units. So here are some of the water level solutions that Onset offers, and we really hit all categories with our water level. I would say it's probably one of the more common products that I'm asked for. There's just a wide range of water level applications out there, but we have a web-enabled station, and we kind of touched on that a little bit, a Bluetooth solution, and then also we have some standalone pressure transducers as well. And I'll start with the remote solution. Again, customers using this maybe for high hazard dams or dam management, or customers that are looking for that near real-time access to their data or alerts. We have in this picture the micro RX station, which is that more compact station. You can see the solar panel built into it, and it will allow for up to 5 smart sensor inputs as well. So we have some of those environmental sensors such as wind speed and direction, rain gauge, temperature and relative humidity. So I have some customers that are really outfitting a full weather station, maybe next to a stream or a lake, and then using that setup with water level as well. You can kind of see the cord coming off of it and the pressure transducer that gets into the water. The top portion of this station, because really the bottom is for water pressure readings, and it will give you a pressure reading, but the top portion also provides barometric pressure as well, so that it can do that compensation and give you a water level reading. Then for the Bluetooth option, this is an all-in-one solution too, where you're looking at pressure. You're looking at the water pressure from the bottom. It actually uses a very similar setup. So you have the water pressure transducer at the bottom connected by a cable to the top portion, and the top portion provides that barometric pressure reading and also the Bluetooth connection. So you could actually, in a lot of cases, many of my customers that have these set up in a well don't need to even remove the product from the well at all to connect right up to it and get that reading right on their iOS or Android device. And they'll get 4 readings. They'll get water pressure, barometric pressure, differential, and then water level as well. So it will do that calculation for you. On the standalone data logger side, where you're looking at rugged non-vented sensors. So we have a couple different options. This is our polypropylene option, so it's going to work in both freshwater and saltwater environments. It's the most affordable option as well. And they're used very frequently, and I get asked a lot for them in wetland mitigation applications or wetland restoration, because they're really trying to find the hydrology of that area, and using, there's a large amount of wells in that small space. So what they'll do is they will drop these in the well for that water pressure, and then they will purchase an additional one for barometric pressure compensation and keep that outside of the well. In our software, our HOBOware Pro software, you can upload those together to get a water level reading. So here are some deploying, and there's tons of methods out there, and you can even get creative and kind of do some on your own as well. But these are some of the common mounting methods that we hear pretty frequently. I would say one of the most common I hear is this first section where it's showing a 2-inch, I want to call it a 2-inch PVC stilling well, usually slotted so that you're getting good flow to the sensor. And if you are using a 2-inch well, Onset does offer a 2-inch PVC well cap that will allow you to either properly mount the logger or suspend the logger inside the well. And then on the right side here, you have a couple different options. You have a tether mount and a post mount. And they're actually using in here, it's a little PVC capsule. It's a U2X protective housing that Onset offers, again, to protect that logger from whether it's biofouling or things, sediment moving around. It really helps to kind of keep that stable in that environment. And it does have the holes drilled in to it for that proper flow to the sensor as well. If you're using one of our conductivity loggers, it's just important to note that you do want it at least an inch from metal, and to also have it vertical. Here's a couple more here with mounting it on a rock or a cement slab or a block. This will actually keep it less visible and kind of avoid vandalism. It's something you hate to think about, but unfortunately it does occur. So keep mounting it on a rock or something to kind of bring it down to the bottom will help. Again, maybe you're using a protective housing around it when you're kind of strapping it to that slab. And that also keeps it out of the way of boat traffic as well. You do want to make sure to use markers or landmarks and know where you left the logger if you're kind of hiding it. So now we'll tie this off with, yep.
It's Douglas. I just want to interrupt for 1 second.
Sure.
So you had the well cap for the stilling well. I just wondered if you had any thoughts on stilling well design or had done any tests to demonstrate stilling wells that might work better in certain flow regimes?
Paul, yeah, I think I've seen you do some possibly in some webinars that I watched maybe.
Yeah, I mean, I wouldn't call us experts in the stilling well design because there's a lot of concern that has to be done in that in terms of separating what zone you're looking at. You have to make sure that your slots in your PVC pipe, your slotted PVC are at the right zone for the water, aquifer level that you want to measure. Yeah, it's yes, because it's water level and it's not usually changing that fast. If except in maybe in wave applications it needs to be a little different. But speaking in your normal groundwater level or tidal levels, slotted PVC is good because it keeps a lot of the debris and sediment from getting into the well. You don't want your well to get a lot of debris in it that could build up and eventually bury the sensor. So that's something to keep in mind. Yeah, 2 inch is a good diameter to work with because you can get sensors in there. You can also get your for reference water level measurements or samples. It gives you enough room to get your sensors and samplers into there. That's we sell 2 different well caps. One that's designed for a cable to come out. So if you're hooking it up to our RX 2001 station or any of our RX stations, you'll want to use the one that's got the cable pass through. Whereas if you're just deploying it, suspending the logger in the well, then you just get our basic well cap, which doesn't have the cable pass through. You want to have a vent in your well cap. So there's some things to keep in mind. If it's a really hot and humid environment, you may want to specifically have extra ventilation in the top of your well to, so it doesn't create, it depends on which logger you're using. But if you're using like our MX 2001 logger, you might need to create some extra cross ventilation. So yeah, it's a big subject area. Then as you get into specific questions, feel free to, give us a call and we can share some ideas with you.
I appreciate the info. I mean, a lot of the sensors that we put out, we're putting into streams, and in California, those are generally very flashy, episodic events when there's big rain. So we're just looking for ideas. Thank you.
Yeah. Yep.
Awesome. So this is one of our customer applications, and our friends at the Billion Oyster Project, they're using a range of our water quality loggers, and they're using it for oyster habitat restoration. In 2014, they started this project just because the over-harvesting kind of left the oyster population in despair. So there's help with students, volunteers, and partners to kind of restore these oyster reefs in the New York harbor. And what they're doing is they're monitoring. They were monitoring before installing the reefs and the oysters, during, and then after, to kind of really map the water quality beforehand, how it's being affected during, and then, how that changes over time. I believe oysters can filter up to 50 gallons of water per day. So they're very, very good source for water quality. And also they're looking at during the deployment to kind of see, because these are in estuary environments, and they're trying to really map, how the oysters react to the water, whether it's, they're looking at conductivity, pH, or DO. They're looking, they kind of map the growth and the health of these oysters in each given area. And here's another application from the Bermuda Institute of Ocean Sciences, and they're looking at, they're doing research for coral reefs and to look at the response to natural and human activity and how it's affected coral reefs over time. And they use HOBO's U22 water temperature loggers. And one of the main reasons they're using that specific logger is because it's a very durable logger, and it has, I believe, 6 years battery life. So they can use it for those long-lasting deployments. And they're looking at the max, min, and average daily values of temperature in these environments. And with that, I can kick it over to Paul to talk about the Buzzards Bay application, and then we can open it up to some question and answer.
Yeah, I get to talk about this application here in Buzzards Bay, which is just off of Cape Cod, or Cape Cod is one of the borders of Buzzards Bay. But I've got a little bit of an inside connection in that my daughter helped with the research in this and putting together some of the research results. She worked with Coastal America Foundation. That's got basically it's a long-term monitoring project. So they're looking at long-term as well as kind of some of the short-term impacts of changing climate conditions, as well as development around Buzzards Bay. And so, yeah, they're interested in longer term effects, average level rises, salinity changes, water temperature changes, of course. And they're also looking at impacts from nitrogen pollution around this bay as development happens. They also have an element of public education, trying to encourage concerned citizens around the Cape and elsewhere to be good stewards of our water resources and beautiful bays that we have. And interestingly, they also were looking at sustainable practices such as seeding oysters at different places around the bay, as Andrew was talking about in the Million Oysters project. So they had an element of that as well. And so they had 5 sites around Buzzards Bay where they were measuring water quality parameters every 15 minutes. They were measuring temperature, salinity, dissolved oxygen. And then once a week, they would actually go out with and offload the data, as well as take pH samples. We didn't have our pH logger at the time when they were doing this research, so they had to manually take those pH samples so they could get a record of that over time. And yeah, so they were able to get long-term history, and this has been going on for several years. And so it's providing the kind of a long-term database. And you can see, just one more thing I wanted to point out is an interesting way that they chose to mount these is they actually mounted the data loggers on lobster traps. So that that just provided a convenient way of accessing the data logger. So they sat down on the bottom, of course, but then he had his lobster license, so he could go out and see his buoys, pull them up, offload the data and redeploy them. And they do a similar thing with crab pots, I guess, out in the West Coast. There seems to be more of a commercial fishery for crabs than lobsters out in the West Coast. So you may see some opportunities for that. So now you can skip ahead, Andrew. So this is just some of the data that was offloaded from one of the sites. There was, as I mentioned, there's 5 different sites around Buzzards Bay. And this particular site was the nearest one to a wastewater treatment facility. And it had a unique characteristic here. And you can see the yellow line is the water temperature. It's going up from June through July is the time frame this particular data snapshot is from. And you can see it's going up pretty steadily, as you'd expect. The dissolved oxygen levels are at the green data here. And you see this interesting phenomena that happens around the June, 18th, 20th, where the dissolved oxygen spikes up on one day, and then the next day it goes down, it gets down below 4 milligrams per liter. And what that was a algal bloom event. And that's the sort of thing you can capture by having a continuous record of the data. If you just go out and doing spot samples, you miss that. But by having a continuous record of the data, you can see these important phenomena, and you can isolate it to factors in the environment, such as that wastewater treatment plant. So some very interesting data. So at this point, I think that's all I wanted to say on this. It's time for whatever time we have left, we're happy to address any questions you have.
All right, well, thank you guys. It was a great presentation. I like the tidbits on, no pun intended, on some of the thoughts on how you can deploy these in the field. That's very useful.
While you guys are thinking of questions, there was one question I noticed in the questions you guys sent in advance. So thanks for sending those. I think we tried to cover some of those in the presentation, what Andrew was covering. And but one of you asked about how to get temperature accuracy improvements, because you were doing a temperature chain sort of application. And I wanted to address that because Greg Sinnett, who was doing the research on the Scripps Pure there, he actually, what he did is he individually calibrated each of the loggers. He had, I think, 36 temperature loggers at different depths and different distances from the shore. And what he would come up with is an individual calibration offset for each of those loggers. And he was actually able to effectively improve the accuracy from what we specify, which is 0.2 degrees C accuracy. He was able to get 0.01 degrees C accuracy using this kind of specialized calibration technique. So we'd have to go out there and recalibrate them on a, I don't know if I think it was on an annual basis, he'd recalibrate them. So that's just one bit of experience that I wanted to share with you, that there is ways you can get better accuracy doing that.
And when he was calibrating, do we recall over what temperature range he was getting those accuracies? Because I imagine that, as the range increases, the accuracy goes down.
Yeah. Well, I guess that's one of the advantages of being in your environment, is my sense is, from an East Coaster's perspective, is the temperatures of the waters are a little more stable there. And I to be honest, I can't remember what the temperature range was, but very much, it's, that was a defined range. Of course, during wave events, you'd get, and if there are storm events, you'd get more temperatures coming in. So yeah, it's probably over a 10 degrees range that he was getting that improved accuracy.
All right, thanks.
Yeah. Other questions?
Don't see any other questions popping up. So at this point, I'd like to thank Andrew and Paul for the great description of the products offered by Onset. And we've got one, let's see, something popped up.
Looked like a link.
A link, yeah, to his recent paper. So that must be Greg's recent paper from Phil Bresnahan. And
yeah, thanks for sharing that. We look, we always enjoy reading about the research, and it helps us understand what you guys are doing better. So thank you.
Yeah, thanks, Phil, for including that. please keep in mind that this is recorded and all the other ones are recorded. So if you want to pass this out to a friend or colleague that missed today's webinar, please do. And with that, I'll just say goodbye and have a good afternoon.
Yeah, thank you, everyone. Thanks,
Yeah,
Doug.
thanks for your time.
Vanessa.
Bye, guys.
Thanks for setting this up too. This is great.